Okay, we are on video number 2. All right, video number 2, and we're looking at now equations with what's called the ideal gas law. Ideal gas law. And this is one of those formulas that I have memorized because it's an important one. It comes up a lot. And not just for solving problems, but if you remember the ideal gas law, you don't have to remember any of these formulas. You just have to remember the one law, the one formula. Ideal gas law is pressure times the volume, PV, equals little n, which is a number of moles of the gas, times R, which is a gas constant, and then T, which again is in Kelvin. Now the reason why this is important is remember that anytime, that's not really what I wanted, but anytime pressure or volume goes up, the temperature has to go up. Well, unless we add more gas. But in a sealed container, N is not going to change and R is not going to change. So if P or V goes up, T goes up. And if P or V goes down, then T goes down. Again, N is not going to change in a sealed container. R never changes. It's a constant. Okay. Now, assuming this all stays the same, if P goes up, what does V do? It does the opposite. So here, if pressure goes down, volume has to go up. So imagine this is equal to 10. So let's just put, let's say if I take N and R and T, it equals 10. Okay. And let's say that P is 5, and then V is 2. 5 times 2 is 10, right? If this pressure goes down, let's say it goes down to 2, then the volume has to go up. So that equals 10. Does it make sense? Okay. So let's solve a question using PV and RT, and let's actually use this to calculate how much of a gas. All right, so let's say we've got a room, and let's just set some numbers here. Let's say it's a big room. Let's say the volume equals 10,000 liters. And let's say the pressure is normal atmospheric pressure, which I believe is something like 2 kPa. I could be way off on that. And let's see, what else do we need? So we have a volume, we have a pressure, and we need a temperature. Okay, let's say the temperature, it's room temperature, 293 K. Okay, so now we're going to figure out how much gas is in there, how many moles of gas are in there. So we just solve these questions any way we would. We can do it with a formula, or we could do it with the long line that we draw. But I'm just going to use a formula here. And let's say, so we have PV equals nRT. We want to know what N is. So we're going to get the RT on the other side of the equation. So we want to get the RT to the other side of the equation. Sorry about that. We're going to get the RT over here. And to do that, to move that to the bottom. So now we have a new equation. PV over RT equals N. All right, let's get out our calculator. So the pressure in the room is 2 kPa, and then the volume is 10,000. Okay, so we have 20,000 on the top, and then the bottom we have R and T. So I'm going to store this in our memory. Okay, let's do the T. That's pretty easy. It's 293. Now what the heck is R? So R is that constant you would look up in a book, and the constant I'm going to use is 8.314 liters kPa over mole K. So there's our number, 24326. Okay. Now remember, this is on the bottom. So our equation, move this off to the side. Let's get back here. What's that number again? 2436. So we're back over here. So we have 3, 6 on the bottom. And then on the top, we have 20,000. Sorry. And then when we get this in our calculator, this is the number, but it's inversed because I divided the bottom by the top. So our answer is 8.2, and that makes sense. We have 20,000 over 2.5. 2.5 goes into 20 about 8 times. So our answer would be 8.21 moles. 8.21 moles. Let's write that down. Equals 8.21 moles. So they're trying to figure out N, which is the number of moles. My units is going to be moles. So I'm trying to figure out volume. My answer is going to be in liters. Pressure is going to be in kPa. T is going to be in Kelvin. Okay, where's our Kelvin? I think I erased, oh, here it is, 293 Kelvin. Okay, last couple of things before we leave you. I'm going to draw a new screen here. There were a couple questions on this test about solutions. So, they're not, again, solutions to questions. But let's say I had a jar of water. Of course, we have to make it blue because it's water. Okay. And into this water, I add some salt. Change all of these, make it a bit different color so you can see that better. Okay, so I have all this that I've added to my water. Okay, now I have a solution. In fact, I have what's called an aqueous solution. Aqueous meaning that the solvent equals water, and here the solute, which is the purple stuff. Okay, did we say that was sugar? Okay, I'm just going to grab one of these. Oops, let's try that again. So our solute is the sugar, and our solvent is the water. That's what forms an aqueous solution. All right. We said that we had the word electrolyte. So let's get that out there. Electrolyte. We said electrolyte is something that's going to dissolve in water that's also going to conduct electricity. So in our lab, we so it's dissolves and conducts electricity. Kind of went off the board there, but you get the idea. That's an electrolyte. Most salts, for example, are electrolytes. And then we also talked about one of the weird properties of water is that water is a polar molecule. So let's review what that means. Oops, let's go back to there. Okay. So water, remember, is an O, oxygen, combined to two hydrogens, like Mickey Mouse. And because of the electronegativity of these atoms or elements, this side, okay, is going to be predominantly positive, and this side is going to be negative. So let me find my polar molecule. And these pluses from one water molecule, hear that? These pluses from one water molecule are then going to cause another one to stick and to stick, and so you have these water molecules that are sticking to each other. And that accounts for some of the properties of water, which would be like things like a high boiling point, a high melting point. Those would be the two basic ones: high boiling point, high melting point. Not everything we put in water dissolves in water. Some things simply just kind of float in the water for a while and settle, and those things would be a suspension. A suspension is something that is it's in the water, but after a while it tends to sink. And there's different types of suspensions, but all you need to know for this is that a suspension is something it's not really dissolved in water, that if we let it sit for a while, it will sink to the bottom. All right, so I think that is it for the test. Reviewing the facts, you should know the three phases of matter, what it's called when we change from each of these phases, and that basically what's happening at an atomic molecular level is that as we get hotter, the atoms go faster and they tend to fall apart from each other, and then as we get colder, the atoms tend to kind of group together and move more slowly. We had these three things we measure with gases: pressure, volume, and temperature. Pressure goes up, temperature goes up, volume goes down. Volume goes up, temperature and pressure go down. And then this one, if temperature goes up, pressure and volume go up, or at least one of them goes up. And again, we're always measuring temperature in Kelvin, which is degrees C plus 273. If you don't want to memorize all those formulas, memorize the one. PV equals nRT. If P goes up, V has to go down. If P goes up, T goes up. If V goes up, T goes up. And then be able to solve problems using this ideal gas law, which we showed you right over here. And then we talked briefly about aqueous solutions. Again, your key terms here are an aqueous solution. We have water, which dissolves some sort of solid or gas. If that solute helps conduct electricity, we call that an electrolyte. And we said water is a polar molecule. And polar molecules give water a high boiling point, a high melting point. It also gives it great solubility. Water dissolves almost everything because these pluses can attach to negative ions, and these minuses can attach to positive ions. All right, that's it for the test. Good luck.